The other thing we focused on, and this was something that I saw a lot in the factories, is get the data at the lowest level possible. So if you can get down to the serial number or the component level information, it's very easy to aggregate that up, and then you can be flexible for your reporting needs. So the factory may want to see it at the serial number level, at the individual piece part level, but your leadership doesn't care about the individual level. They want to see everything in aggregate.
All right, Jennifer, we've got quite the episode today. Brian is an inspiration.
I mean, that's an understatement. I think that our listeners are really, really going to enjoy some of the vision that he brings to this, and some of the clarity and the pace at which he's moving this forward. I think they're going to be inspired by that.
Yeah, I mean, he's doing really important work at BAE, so the kind of thing that gives you confidence. You're like, all right, there's really good people in place here. I hard to pick a favorite moment, but I just like the evolution from the depths of his physical science. Like, he's talking about how fast the carbon nanotube was. He's watching the furnace and actually seeing it grow, and the kind of excitement over an individual, thing being built up, to the scale of what he's working on now with like digital thread, right?
Yeah, absolutely. And of course, I'm always so inspired to see how people are emerging as leaders and how they're pulling people along and getting this into the hands of people. And that's where the rubber really hits the road. And it's hard. And it's inspiring to see people who are able to do this and get that vision rolling out throughout their companies and the industry. These are the people that are absolutely shaping the future of manufacturing. And it's so exciting to see that cake baking.
He's a great teacher. He's someone that you can see is enabling others with tools and capabilities. And so that's part of his magic. Anyways, let's not hold people back. Let's
do it. Let's get into it.
We're excited to have Brian White with us today, a data analytics leader at BAE Systems, a driving force in aerospace and defense manufacturing transformation. Over the course of his career, Brian has built on his expertise as a physical scientist, a data scientist, a process expert, driving operational excellence now, helping BAE turn complex data challenges into clear, actionable insights. He's got hands-on experience leading teams in secure, highly regulated environments, working on some of the coolest and most important stuff in the world, advanced edge computing, optimizing production processes, just the whole gamut. So it's going to be really fascinating to see where we go here. He's on the forefront of innovation in aerospace and defense, and looking forward to hearing about it. Brian, welcome to the show. Great to have you.
Thank you, Andrew. I'm really excited to be here. You guys have a really, really cool show lined up, and I'm excited to be part of it.
Yeah, no, thank you so much. We're really excited to talk about your work as a data scientist, a data leader in aerospace and defense. I just start out, I guess, with like a day in the life, because one of the things when I first met you, Brian, I'm not like obsessed with titles. Hopefully people aren't, but I was like, your title is cool. And like not all companies even have, like it's interesting how different companies are building positions in different ways. So like tell us about your day in the life, or maybe your week in the life. Like, what does it typically look like? Who are you working with? What kind of problems are you solving and trying to overcome?
So we're constantly trying to teach, and we're constantly learning from the business. And so we work with folks on the factory floor, and we work with leadership and everybody in between. Our goal is to create a solution that works. We call it from the factory floor to the boardroom. And so we're learning about business processes and how data is curated. We're understanding how data is put into our various business systems. And then we're trying to figure out, how do we extract meaningful content from that data and give it back to people in almost real time. So if there's a metric or a measure or a piece of data that would make their life easier, whether it's just a simple automation of an Excel file or aggregating data, all the way to very complex metrics around quality, cost, and delivery, we'll do all of that. And so my team will focus on some data engineering, so curating data from our business systems. We focus on data visualization, so turning that into a visual within a Power BI or Tableau or other visualization platform. And then we're starting to dabble in AI ML, and most recently starting to play in Gen AI. So how do you get better information to the user, whether it's an operator on the factory floor building product or a leader trying to make a decision for the direction of the company?
Yeah, the whole gamut from
the whole gamut.
data
Yes.
collection to visualization to AI, and from, I like to say, factory floor to the boardroom.
Yes.
That's a big jump.
It's interesting. I want to go back. I don't know, most of our listeners may or may not know this. I want to talk about back to the beginning of your career. Let's start and talk through that a little bit. You earned a PhD at Columbia, where you focused on chemical vapor deposition systems for carbon nanotubes, and then spent nearly, I think, 10 years working as a physical scientist at Nanocomp. Is that right?
Yep.
So talk to me a little bit about that. Walk us through that, what we were working on and the focus that was present throughout that role. And then specifically how it influenced your approach to problem solving, data analysis, ultimately your path into data science and operational excellence.
Yeah, so at Columbia, I worked for a professor, Professor Nicholas Turo, who was a godfather in photochemistry. So he was really pushing the environment in spectroscopy, photochemistry, just understanding chemical reactions. And he was later in his career, so he was focused on giving his graduate students the best experience they could have. So I actually he required us to have two advisors. So Nicholas Turo was my advisor in chemistry, and then Stephen O'Brien was my advisor in material science. So I had kind of like these two masters. But what it did was it gave me the ability to kind of see problems from two different angles. And so I had projects that I would work on that had more of a chemistry perspective, and then I had problems that I would work on more from a material science perspective. In both cases, Andrew, as you know, in getting your PhD, it's all about data. It's about collecting data, analyzing data, distilling that data, and then making some decision based on that data. From the time I, even started in college and then into grad school, I was very data driven in my daily life and in my approach to solving problems. Chemical vapor deposition was one of the areas that I really latched onto. It was very exciting to me. This was when carbon nanotubes were starting to become a really big research topic. They just released the first forest growth paper on this, and everyone was trying to reproduce it. And so doing stuff in chemical vapor deposition, there was a lot of information out there, a lot of people working on it, and it was trying to figure out how to best make it work in your lab. And so we were constantly collecting information, whether it be temperatures or concentrations or flow rates, and then trying to make decisions on where to go with the next experiment.
I'm always tickled by when you say that because, I did my also co-advised in chemistry and material science, but I'm like with you there exactly.
Yeah.
You're like got the system and you got to collect the flow rates and the temperatures, collecting data, probably through some pretty rudimentary system.
Oh yeah, so it was all like hand dials at that point. So we've come a long way since then.
I used a lot of LabVIEW. I don't know about you, but
We were even more old school than that. Like it was literally
there
we
you
set
go.
things. Nothing was manually or nothing was automated. Everything was
Okay.
kind of manual control. So I would sit in the lab running these reactions every day. I didn't have anything automated at that point.
Okay, but yeah, keep going. So you went to Nanocomp and then, yeah, what did did you keep working on physical science there? Did you start evolving into like process optimization?
So in Colombia, we were growing carbon nanotubes on substrates, and we would grow like a 2 millimeter by 2 millimeter silicon wafer. We'd grow a few nanotubes on that surface, and at the time, it was really focused on spectroscopy. So growing individual nanotubes on a surface so that you could do spectroscopy of those things. And we were still kind of early stages of understanding what carbon nanotubes were, single wall versus multi wall. And so the most I had ever seen, I think I had a 1 gram jar that we purchased for some experiments we're doing in the chemistry lab. But when I went to Nanocomp and sat down for the interview, this was late 2016, early 2017. So they were just starting up. I think they had a dozen employees. And I sat down in front of this furnace and I could see carbon nanotubes growing, like coming at me. And I almost fell out of my chair. I was just blown away by the technology at the time, going from nanograms to now, grams or tens of grams an hour. And so I finished up at Columbia. I went immediately to Nanocomp. We spent the next several years just trying to scale up both the properties and the capability of our CNT reactors. So we had a lot of investment from the government, a lot of investment from small business innovation grants. We had some commercial technologies, but it was just kind of an exciting time to be scaling up these new processes. So there was a mix of chemistry, physical sciences. There was process automation and process development. So I learned a lot about automation of processes. I learned how to control things, and we generated a ton of data. I think probably the hardest part, though, was that the data that we needed was in an environment that you couldn't access. It was a 2,000-degree furnace. Anything you put in there would get gummed up and ruin the reaction.
Oh, yeah.
And so trying to understand or gain enough data to make better decisions was a challenge.
Was this one of these like people that haven't worked in material science? Like you get like the what kind of white ceramic interior like type of thing that just
Yeah, we
glows
tried
out?
quartz early on so we could see, and that ended up breaking. So yeah, we went to a ceramic tube. It was 4 feet long by 6 inches in diameter, so you could see up the center of it, but you couldn't see from the side.
It's
Um,
just crazy. I know looking at these things, they're so hot, and you're like, I've never. It's like being like, it's just it's not like a huge thing. It's a small tube, but
yeah,
it's like being right next to magma or something. You feel like
yeah,
coming off your
yeah.
face.
Even sunglasses, like you literally would feel the warmth coming off of this thing, and it's all in hydrogen, so it's a really unforgiving environment, difficult to probe and understand. But while I was at NanoComp, this mentor, Bob Cassoni, introduced me to Jump. Jump is a statistical software platform.
Mm.
And he helped me really understand statistics. He helped me understand data collection. It was my first exposure to data automation, my first exposure to SQL. And so learning Jump was kind of my foray into data science and data and analytics. So I'm really thankful for that opportunity. But we had all of this data that we were collecting, and we were able to start to distill some of this in the statistical software package that we had. This was long before some of the big ETL processes, before data visualization. We were just trying to understand what we had. So we were doing multivariate analyses. We were doing designs of experiments. Just trying to get more insight into what we had and try to make connections between the disparate pieces of information that we had.
That seems to be one of the key kind of connection points for you. Yeah, I want to try to bring AI on this one just real quick. Hey, chat. So we're live on the podcast here with Brian White from BAE Systems and learning about his move from physical sciences to data science. He just mentioned the analytics package Jump that he learned, which was key. Like, what is that and where is it used?
Brian's probably referring to JMP, pronounced JUMP, which is a statistical software package developed by SAS. It's widely used for exploratory data analysis and visualization, especially in industries like manufacturing, engineering, and the physical sciences. JMP is particularly powerful for analyzing large data sets, finding patterns, and running statistical models without needing heavy programming knowledge. It's a favorite tool in Six Sigma, quality control, and R&D because it helps scientists.
Cool. So, so yeah, before ETL, extract, transform, load, more powerful data engines and that kind of thing, you were getting into it. So I guess let me jump to BAE here again. And, you're in the electronic systems business unit, right, of BAE. And one of the things that's fascinating, I mean, I know obviously you're doing extremely important work and plenty of things that, can't be talked about by nature of them. But one of the things I think that's known on the outside, BAE has this long history here. I think the unit you're in acquired business from Boeing and Lockheed in the past. So you've got all kinds of business systems that you have to deal with in this extremely important environment. So I guess I talk a little bit about as you're now in this new capacity, not working with a single tube furnace and a physical process, but so many different facilities, different systems acquired in. Like, what are some of the key lessons you've learned about creating systems that can do data analytics at scale and collect that data and create actionable insights? That seems like an altogether different level of challenge from where you were to what you're tackling now.
Yes. Yeah. So when I moved to BAE, I actually started as a process engineering manager. So I was managing process engineers and operators on the floor, um, you know, helping them build products or kind of work through the MES system that we had. As I was watching them, though, I realized that they had all this information, but they couldn't access it. They couldn't see it quickly. None of those automated. So they were manually pulling reports. And so what I did was I tried to focus on understanding how does the data get generated. So understanding that process behind generating data helps you understand the data you're looking at. And so as you talked about multiple sites and multiple business systems, understanding how that data is created, whether it's an MES or an ERP or a QMS system, even if it's multiples of those, understanding the data makes it easier to blend that data together. The other thing we focused on, and this was something that I saw a lot in the factories, is get the data at the lowest level possible. So if you can get down to the serial number or the component level information, it's very easy to aggregate that up, and then you can be flexible for your reporting needs. So the factory may want to see it at the serial number level, at the individual piece part level. But your leadership doesn't care about the individual level. They want to see everything in aggregate. So being able to get things at the lowest level and then aggregate them up makes it easy for reporting, whether it's all the way down at the factory or all the way up to that boardroom. And then something that I really pushed my team to do is build solutions at the global level. And I say global, at the top level of the business. If you build a single report for a person or a cell, it will take you X hours. If you build that same report for the broad business, it may take you X times 1.5. So it's not a ton more work, but long term, your maintenance has gone down exponentially. If you had to build that report for 15 different groups, you now have 15 projects to manage. And every time they want to make a change, you have 15 different things you have to touch. So we've really pushed my team, and I've pushed the business to build these global solutions and then have the ability to aggregate or filter down to the level of information that they want to see.
Just a quick follow-up question. Is that a philosophy that you've had or that BAE has had for a long time of kind of centralizing, or is that something new that you drove?
When you bring all these businesses together, oftentimes you see silos, right? So this factory does it this way, and that factory does it this way, and then you're spread out across the country or the world, and you have different cultural approaches, or they use things differently. So it's really been a focus that I've had, trying to create less work for myself and less work for my team, by working with the factories to accept a solution that meets their 80 or 90% need, but is just less maintenance and less overall work for my group.
Yeah, so I actually have a question to follow on that. I would imagine that it's made, infinitely more complicated by the unique challenges and opportunities for data analytics in A&D, where, you operate in a high stakes environment where quality and reliability are not negotiable. So, and then obviously regulatory constraints, and you're still trying to drive operational efficiency. Walk me through a little bit how you approach that balance, designing the data solutions inside of that context.
So not a surprise that aerospace and defense is notoriously slow when it comes to new technologies. I think a lot of it comes from government and DoD, Department of Defense, and the requirements that they impose on us. So there's DFARS, which is the Defense Federal Acquisition Regulation Supplement,
Yep.
and CMMC, which is the Cybersecurity Maturity Model Certification. And they really define how you can work with data, the environments that you can work in, and how you can use your data. I work very closely with IT to make sure that we're using solutions that are acceptable within both DFARS and CMMC, and kind of work within our environment. As a result, almost everything we do is on-premise or on-prem, and we just build our solutions out and deploy them in very robust on-prem solutions that are kind of behind firewalls. We're still able to use a lot of the tools that you would think about in industry, whether it be an ETL tool or a SQL database. It's just everything is on-prem, and we don't have access to a lot of the cloud capabilities that the rest of the commercial world is leveraging pretty heavily.
So you have a greater reliance on-prem, on tools behind walls, but still nonetheless an ability to drive that and do things. I guess let's shift to AI. There's so much happening there. And we talked a lot, your own journey. You talked about the jump, the JMP package, and getting into JMP and getting into statistical analysis. And now you've talked about kind of being able to scale ETL and some of the requirements. But what's changing in your view with AI? And maybe some things are getting harder, maybe some things are getting easier. And like, what's a shift? Like, because you mentioned in the beginning, generative AI specifically, something you're looking into. What's something that you think people in aerospace and defense or manufacturing broadly still don't fully grasp about the impact of it from your perspective?
I'm really, really excited about Gen AI and what it can do. And so I'm really excited for it to be adopted within any environment that I'm working in, whether it's at home or at work. So I don't think that people fully comprehend how powerful it is. They don't understand how it can connect all of these disparate data sources together to create just faster insight, faster time to understanding something. And it's growing so quickly. Hopefully it will be kind of commonplace in the next few years. But a statistic came out a couple months ago. 40% of adults had used Gen AI in under 2 years from when it was first released. We think about November of 2022 as like the day that ChatGPT dropped, and our world was never the same. In retrospect, the adoption of the personal computer, and the adoption of the internet took much longer than 2 years. And so it just goes to show that Gen AI is a really, really powerful capability. And I think it's really going to change the way that we live, but it's going to change the way that we work. And it's just going to be time for businesses to adopt, and they need to adopt like some demonstrated use cases and kind of explore with Gen AI in their businesses.
Yeah, wouldn't you say too that I'm imagining now, but I'd love to hear your take on it. Early on, you talked about looking at like MES, QMS, ERP systems, and in an environment like aerospace and defense, in some ways, there's even more data in other environments, but it can be even more broken up into pieces and notes and like the kinds of things that you needed a human to look at. And so if you have secure access to a generative AI, it feels, I mean, it's transformative for every industry, but it
Mhm.
feels to me like it can be especially transformative in an industry where data is even more broken up into pieces and really relied on human understanding of it.
Right.
What's your take on that?
We are a kind of a full stack developer, right? We create our circuit cards, we create our next level, and we create the final deliverable to the customer. Thinking about connecting the information for each of those pieces, the circuit card to everything else, it's a big task, even for a human to think through how all of that's connected. It's daunting, and so Gen AI can do all of that for us. You kind of let it loose on your data, show it where your linkages are, and then you let Gen AI kind of build out the solution or do the analysis for you. Being able to build, connect Gen AI to our QMS and our MES and our ERP systems is going to be a huge step for us when we're able to do that on prem. It's really exciting. It'll kind of take some of the pressure off of myself and my team to deliver these strong insights to the business.
Yeah, that's interesting. We've heard a lot of buzz, especially over the last more and more over the last 2 or 3 years than ever before on, the concept of the digital thread, connecting, the data, design, field data, and be able to get that continuous feedback loop, right? It's interesting because this tracks, we do hear this a lot from our aerospace and defense customers, that they really, really want to push that end-to-end digital thread and get that loop in place. For that reason, I think that A&D is probably going to be one of the industries that actually champions and leads this more than others, even given the constraints that they have in getting that data, accessing that data, storing that data, who can see it, when they can see it. What's your take on timeline for this to become a reality? Do you see it accelerating? Do you seeing some major bottlenecks and hurdles in that? What's your thought on that?
So I think it is accelerating, and a lot of it goes back to our customers. U.S. government and Department of Defense are now requiring digital thread capability as part of the contract. So if you're not going to win a contract unless you have digital thread capabilities, you better get digital thread capabilities. So I think A&D will adopt sooner than they would have naturally, just because they have to build an infrastructure, whether it's collecting data on the design and engineering phase, or being able to connect that design data all the way through the actual build, and then what the equipment is doing. So having middleware connected to your engineering information. So A&D is now trying to figure out how to best implement that. And they're going to start building infrastructure now. They're going to start to collect all that information and then figure out how to connect it together. And I think that's where larger platforms or potentially Gen AI is going to be key in connecting that information from the engineering phase all the way through the final design, building, and then sustainment of that product.
Yeah, I guess my follow on there would be, do you see the introduction of AI into it? Do you see that creating a slowdown in what you can adopt and how fast you can get some of these in, or do you see it accelerating it, or both?
I think it accelerates it. I mean, there's going to be a hurdle before, like, to get everything stood up. GPUs are still hard to come by, but building out that infrastructure, building out those capabilities, figuring out how Gen AI works with your systems is going to be tricky. But once that's there, I think it accelerates the digital twin, the digital engineering, and the full digital thread piece.
Agreed.
I was just reflecting on your answer to this question and the one before. It's like you can feel your excitement for digital thread, which not that long ago was like, yeah, it's a buzzword. Everybody loves to throw it out. But like, no, it's a thing. And by the way, the government's requiring us to give digital
Yes.
thread capabilities. That's
Yeah.
how far along it actually is. And then your answer before was about how you're like, I'm extremely excited about generative AI. It's going to free up my team's time. And I love that you're like, waste no time on like, oh, wait, what? I wanted to do that bespoke analysis here. It's like, no, you're like, and even 3, 4 questions before we talked about, I asked, was BA having the centralized data analytics culture to share reports? And you said, I really championed that. So it's clear you've been seeing the opportunity for scalable data infrastructure and insights. And Gen AI now can kind of take on all these bespoke needs, and it's accelerating the ability to put these larger data sets together, which is enabling the systems mindset that you have. So I think that's just a really exciting picture coming together. And I guess if this continues materializing at the pace that it is, and even that it's accelerating, as you said, in other words, a digital thread with information from design, from production, the factory to the field coming together. I don't know. Can you paint any pictures of what that looks like for you? Are there, again, I know the area you work in is protected for good reason, so you can't give any exact examples, but are there any shapes of what this looks like that have been published publicly or you can talk about of like what are kind of the use cases? How does it transform the industry in 5 or 10 years when these digital threads with AI are a real thing?
Digital twin was a big term, several years ago, and I didn't quite fully understand what digital twin meant. And then I sat in a Tesla and I saw the car, I saw the people, I saw the environment, and so I fully understood what a digital twin was. I think as we build out this digital thread capability, we build out the digital twin. We can now empower our operators to look at designs, to look at capabilities that the engineers have created. Now, if you have a board or a module or something else, and you can kind of explore it and you can see what it looks like or how it was designed, you can kind of zoom in on where a cable or a pin should be. It just makes the operator more educated about what they're building and have a better understanding to build something right the first time. But with this whole digital thread capability, I really envision a more empowered workforce. They're going to be more efficient. They're going to be more capable. I see them working on machines that are connected across the process. So Tim Burke at your last session talked about a connected SMT line, right? From your SMT printer and solder print inspector all the way through the AOI. How do you get information from that final step, that AOI, all the way back to your SPI or your screen printer to tweak the size of a space or to increase the amount of solder paste that you put down? With that connected process, you can now create real-time feedback on the processes and defects and immediate responses are generated for the operator. So downtime occurs or a defect occurs, they immediately know how they can fix the process going. And so they don't have to stop the line and do a lot of analysis. The information is almost presented to them, tweak this nozzle or turn this knob. So ultimately, I see less downtime. I see more flexible lines. I see more compliant products, so fewer defects.
Yeah.
And I'm envisioning, even further out, kind of closer to the 10-year, you have these lines that are flexible, and you have an ERP system that's looking at your demand and looking at available material and labor, and they're able to flex real time, right? So let's not build this product here. Let's build it over here, or let's move material to this factory, and we'll move this labor to this line. So it becomes a little more flexible, but it becomes much more efficient. So we should be able to increase throughput in our factories, with the same resources that we have now.
Yeah, I heard the connected worker really in tune with what they're having to work on. There should be cable here, this exact thing, that flexible, smart scheduling you were saying, being able to dynamically schedule things out. And you mentioned, fewer defects and fewer issues in end products. I remember I was talking at another point to somebody at Lockheed, and I was blown away. They were talking about an end combat system that they were working on, and there's an issue, and how it wasn't just a matter of plugging in a cable somewhere. Like they literally deconstruct this jet, for example, and then create custom test equipment for a component that they didn't build in that plant, was built in some other plant. And so the ability to have obviously things just higher quality, but even having digital copies, that linkage, not just back from the AOI, but from the pieces, that's going to take a while, but that's really exciting.
We're generating the data now, which is the exciting thing. If we can just figure out how to harness it, leveraging middleware to pull all this data together into centralized systems and then unleash your Gen AI model on top of it, it's going to be a really, really exciting next few years within BAE.
Yeah, we're seeing the same thing. Super exciting. Super exciting to see. It's like you said earlier, we're super excited to see how far it's come, and honestly, how fast it's come in that amount of time. Once people start to learn some of these best practices from each other and some of these best processes, it's just amplifier effect. And we're seeing that already. It's amazing. I want to go back just for a quick second and talk to you about, it's definitely been the case for us, I think, without deviation, that the success of these kinds of initiatives inside of an organization is inextricably tied to the ability for leadership to articulate vision And then to put process and methodologies in place. You talked about, empowering that workforce. And I think that's tied to strength of leadership and strength of being able, like I said, to articulate where we're going and the timelines we're going. But it's a heavy load sometimes. Talk us through how you do that. Talk us through how you get people aligned around the goals and some of the challenges and some of the successes that you've seen in doing that.
So I think it all starts with trust. Like how do you build up trust, whether it's trust with an operator to give them information or trust with a leader that they're going to believe what you're selling or you're telling them. To build that trust, it's just performing, right? So an operator needs some information, automate the small stuff, whether it's a faster report or getting them information in a more aggregate manner. Doing those small things and then building a rapport with them builds that trust. And so then when you go to them and say, hey, I have this new tool or I have this new solution, could you try it out for me? We've been leaning into our factories and finding early adopters that will kind of work with us as we build out our solutions. And it's really important to get feedback early and often, so almost like an agile environment, so that in 3 months you're delivering something that's great, as opposed to in 3 months you deliver kind of your first prototype that you think is perfect, but it's still going to have defects. So working with early adopters, working with your factories, building that trust, that is the best way to lead within your factories. With leadership, again, it's just execution, showing them metrics that matter. Ask them, what are your pain points? Not what can AI do for you or what can this ETL process do for you? What are your pain points? What keeps you up at night? Is it delivery? Is it quality? Like, what is it?
Yeah.
And then from there, working with them to identify the metrics that matter. So having them be a stakeholder in the work that you're doing helps build trust and a relationship. So then when you come back to them and say, hey, this is what I can do for you with this capability, and being able to explain that in layman's terms, but also educating them. I think one of the biggest challenges that we have right now is data literacy. Everybody's heard of data. Everybody's heard of Gen AI at this point, but how do you use it? How do you understand it? How do you interact with it? And getting people more data literate to whether it's using a tool or being able to do an analysis or understanding what they're looking at is a really important facet of the work that we're doing. So we're really focusing a lot on education and trying to make things both intuitive but also powerful for our factories.
Okay, we are now going into the rapid fire questions, Brian. Here we go. Is there a book, movie, or TV series that inspires you when thinking about the future of manufacturing?
Just read the news right now. I think the future of manufacturing is happening with Gen AI and all the stuff that's going on. We just have to implement all that we're seeing out there from some of these tech leaders, and we're going to be in the future of manufacturing. But if it's an actual book, I would say I read a lot of sci-fi because it is way out there. It's not 5 or 10, it's 30, 50 years out. There was a book called The Diamond Age by Neil Stephenson, where he envisions this world of nanotechnology and everything is built atom up. With my background in carbon nanotubes and nanoparticles and nanocrystals, I'm really excited about an environment where you could actually build things atom by atom. So I'd say The Diamond Age by Neil Stephenson.
Cool one. Great author.
Very cool. All right. Which leader or innovator in technology or engineering do you admire the most or greatly, and why?
So Elon Musk, but before he got into politics,
right?
The vision he had in developing his Tesla gigafactories and the approach to research and collaborative engineering is inspiring. And his vision for electrifying the world is where we need to go. But he's just a really good job of kind of explaining his vision and his future.
What piece of technology outside of manufacturing has had the most impact on your life?
The internet, because I have access to everything at my fingertips. And it has changed the way that we interact with data, and we have access to everything, whether it's an intranet or an internet. I would say that just flow of information is a life changer.
Agreed. I feel the same. All right. If you could instantly acquire any new skill or knowledge area, what would it be? Why?
Understanding financial markets. It's what makes the world go round, and I am so confused. So yeah, I really like to better understand the financial markets.
You could definitely make the money, yeah. Okay, Brian, in a few words, what advice would you give to young engineers or innovators? There's a lot of people who I think look at the impact you're having in the career and think, wow, how do you get to that point? What advice would you have for them starting out today?
Ask questions. Just constantly ask. You need to better understand everything around you, whether it's the data that you're collecting, how a process works, how a machine works. And people love to talk. People love to talk about what they're doing and share their knowledge. So don't be afraid to ask a question. It may seem silly, but it'll give you a much better understanding of what you're looking at, what you're working at, and it'll make you smarter about everything around you and be able to grow faster.
Brian, this was amazing. Thank you so much for coming on the pod. It was really a pleasure having you.
Thank you for inviting me. This was a lot of fun, really exciting to think about where we're headed with Gen AI and manufacturing in general. And I'm excited to share kind of my career and hopefully inspire others out there.
Thanks for the work you're doing. Keep doing it. We're excited to check back in.
It is inspiring. So thank you for coming, Brian.
Thank you both.